few of you were asking for some help on a couple of these review problems, so I figured I would just make a quick video to help you guys go through them. So in number 4, they want the number of distinguishable permutations. So that means we want to figure out the different ways that we can rearrange the letters of the word calculus. So if we count, there are 1, 2, 3, 4, 5, 6, 7, 8 ways that we can arrange them. And the number of permutations would start out as 8 factorial. But because we have repeated letters in here, we have a couple C's, a couple L's, and a couple U's, we have to actually divide out the ways that those letters could also be arranged. So we want to take out the duplicate ways that this C would switch with that C, or that L would switch with that L. So we're going to divide out 2 factorial to take care of the 2 repeated C's. We're also going to divide out by 2 factorial to take out the repeated L's. And we're going to divide again by 2 factorial to take out those repeated U's. You'll notice the answer key in the book also put a 1 factorial and a 1 factorial, but that's just to show the different ways that the A and the S could be shuffled up in there. And it's really just 1, so I'm not going to bother with that. So in the end, I'm going to end up with 8 factorial divided by 8. And if I think about how that expands, that would be 8 times 7 factorial divided by 8. And that would cancel that out. And so my answer would be 7 factorial, which is just 5,040. So there are 5,040 different ways that we could shuffle the letters of calculus and spell different words. All right. The next question that some of you had was number 5. And again, we're just using this formula for our permutations. So if you think back to our formula where we have n objects and we're taking r at a time, our formula for the permutation is to do n factorial and then divide that by n minus r factorial. So I'm going to use that to set up both sides of this equation here. I'm going to use my permutation formula, but instead of putting n factorial, because on the left I have n plus 1, I'm going to put n plus 1 factorial. And then in my denominator, it's supposed to be n minus r, so I'm going to take n plus 1 minus 2. And n plus 1 minus 2 is really just n minus 1, and that also gets the factorial. So this is my n factorial coming from the n side of my permutation, which was really n plus 1. And this was my n minus r, which was n plus 1 minus 2, which simplified to just n minus 1. I'm going to do the same thing on the right side of my equation. So I have 4 times now the permutation formula with an n and a 1. So on this side here on the numerator, I'm just going to keep that as n factorial. And then my denominator is going to be the n minus 1 factorial. Now you'll notice that both sides of my equation have that n minus 1 factorial, but instead of canceling them out, I'm going to actually simplify each side of my fraction. So to expand that, think back to when we worked with our factorials. We take our larger factorial and we expand it until we match up with that lower value there. So n plus 1 here is my larger number, and I'm going to just keep subtracting 1 until I match up with that denominator there. So I'm going to get n plus 1. If I subtract 1 from that, I'm going to get times n. And if I subtract 1 from that, I'm going to get n minus 1 factorial. And that's going to match with that n minus 1 factorial in my denominator, and those are going to cancel. And on the right-hand side, the numerator was the larger value because n would be bigger than n minus 1, so I'm going to do the same thing. I'm going to keep that 4. I'm going to expand that numerator as n times n minus 1 factorial over that n minus 1 factorial, which would cancel that out. So now what I'm left with is just a regular equation here. I can distribute the n here to get n squared plus n on the left side. And on the right side, I'm left with that 4 and that n, so I'm going to be left with just 4n. And I'm just going to solve this equation now. I would subtract 4n from both sides to get all my variables on one side when I have a quadratic. And when I factor this, they have a common factor of n, so I'm going to factor that out. And that's going to leave me with n times the quantity of n plus 3. And so now my answers are going to be either n equals 0. Oh, that should have been a minus 3n. Sorry, guys. That should have been minus because n minus 4 would be negative 3n. So then I'm going to either be left with n equals 0 or n equals 3. And if I think back to my original question here, my original question wanted me to have 0 options, take 1. That doesn't make sense. If I have nothing, I can't take 1 from it. So that value for n equals 0 doesn't make sense. So the only answer I can be left with would be n is equal to 3. And if I use n equals 3, then that equation would hold true. Okay? Now the next problem is number 8, and there's actually 2 ways we can work through number 8. We can kind of do it logically. If he has 5 pairs of socks, and no 2 pairs are the same color, 5 pairs of socks really means that in that drawer he has 10 socks. And out of those 10 socks, 2 are one color, 2 are another color, 2 are a different color, and so forth. If he randomly selects 2 socks from a drawer, what is the probability that he gets a matched pair? So when he first goes into the drawer, his first choice, there are 10 socks that he can pick from out of the 10. So his probability of getting the first socks is 1, right? There's a probability you put your hand in there, you get a sock. But then once he goes in that drawer, he only has 9 socks left. And out of those 9 socks, since they were pairs, there's only one other sock that would match the first sock he grabbed. So if I do this logically, my answer would be 10 over 90, or 1/9. And if you make that a decimal, you make that a decimal. Your other way to do this would be using our work from this section here. So trying to put it together where we go ahead and use our combinations or permutations. Since order doesn't really matter as he's selecting these socks, we're going to use a combination. So the first thing we're going to do is figure out all the different ways he can get 2 socks. So all the ways he can get 2 socks would be to go in the drawer, there's 10 socks, and he can randomly choose 2. And if he does that, there are 45 different ways he can do that. But out of those 45 ways, there's only 5 pairs of socks that are actually going to match. So the probability that they match is going to be, oops, can't spell, the 5 ways that actually do match out of the 45 ways that can possibly be made. And if I reduce that, once again, I'll get 1/9. Okay? So basic probability, you can do it logically. Sometimes I find it's easier to do these problems logically, but when the numbers get bigger or you have a lot of selecting to do, sometimes it makes more sense to do your combinations. All right? And then lastly, number 9 is a basic probability type problem where you have a bunch of different types of people that they're studying. So we have students, faculty, and administrators. Some of them are in favor of this proposal and some are opposed to it. So when I'm looking for the total here, we're going to be looking out of 500 because there's altogether 400 students, 75 faculty members, and 25 administrators. So my probability of getting one person out of that list would be 1 person out of 500. But now when I go and I look at certain criteria for these probabilities, I want to find out the total that match the description out of that 500. So in A, if I want a person who does not favor the proposal, when I look at it right now, these are all the people in favor, and these are all the people that oppose. So there are 208 people right now out of the 500 people that do not favor the proposal. So the probability that they don't favor would be the 208 out of 500. And you could reduce that fraction or round it to your decimal. Got the decimal to be about 0.416. Now the second one wants to know, well, what's the probability that they're a student? So if I go look at my table, out of all of the people, there are 400 people that are students. So my probability that they're a student is going to be the 400 out of the 500 that are there. And again, you can reduce that. You can get your decimal value and work through that. And finally, for letter C, they want to know what's the probability of getting a faculty member who favors the proposal. Now this one, we're still coming out of our pool of 500 people, but this time we want to go for faculty and favoring. So if I look at my chart, there's only 37 people that fit that criteria. So it's going to be 37 over 500, and again, you can convert that to your decimal. Okay? So if you still have any questions on these probability questions, let me know. And you can reach out to me via email